Matrices. So you can just pick a variable name, A equals, assigned equals, excuse me, and matrices, insert matrix. You can, anyway, you can choose any size you want. 2 by 2 is good for illustration, so we'll do that one. 1, 2, 3, 4. Enter numbers into it. Pull it down a bit so we can see it. B assigned equals. I'm going to make it a vector. So let's see, 3, 4, 5. Oops, backspace. 5, 6. And I'm going to do another matrix C. C assigned equals. I'm going to do something a little different here. There's a function called augment. I could have just typed in 5, 6, 7, and 8. Let's do C equals 6 and 8. And I'm going to change one of the elements in B. So I can do B, vector matrix operations. So I can pick out an element of the matrix. So B of element number 2 equals, index must be an integer not less than the origin. I'll get to the origin in just a second. In fact, that's a good time to show it now. There it is. Origin. Not greater than the last element. The origin is 0, so the only index arrays valid for B are 0 and 1. I entered 2. It doesn't work. You can change the origin. Basically, the way the indexes count is 0, 1, 2, 3, and so on if the origin is 0. And if it's 1, it starts doing 1, 2. Okay, we've got B2 equals 6. I want to assign it equal to something else. Assign equal 7. So that's how I can change and then I can just type out what B is. B, there, I've just changed B using the matrix, finding the right index, matrix index. Okay, I can augment. I can go B equals, or I'm going to make it assigned equal, assigned equals. Function, augment. Basically, this is where you put matrices side by side or up and down. So you can augment a matrix, and the first matrix I want is B, and the second matrix I want is C. C. And then I can get rid of the other stuff. I don't need it. I'm not doing a whole bunch more. If I do that, I get another matrix, D, comma, E, comma, F, comma, G, H, and so forth. But I've only got 2. This shows you how you can just keep stringing matrices together. Hit the equal sign again, and I get B is 5 and 7, C is 6 and 8. Voila, I've got this. We can multiply. Now, if the matrix dimensions don't agree, just like with MATLAB, you won't be able to multiply. So multiply A divided by B. Now, you can divide matrices just like in MATLAB. The only trouble is you don't have a way to divide from the left and divide from the right with Mathcad. Multiply, divide, A, add. Oops, I want A, I didn't want Z. A plus B equals. A minus B equals evaluation equals. Okay, so that's basically entering values in matrix, picking out some picking out some elements, and so forth. The the augment command, you can also stack matrices. There's a whole bunch of functions. You can read about what they all do. There's a zillion of them. There's a few operators, cross product. Return the column of a matrix. Let's see. So the index we can refer to, and I put the origin equal 1, didn't I? Yeah, there, calculation, I put the origin equal 1. So if I refer to 2, 2, I refer to this index of A, it'll give me second row, second column. Oops, there we go, right there. So I can, and you saw how you can change. You can change an individual value in MATLAB too. Okay, so we've got, you can delete a row or column, and basically you can go up here and just delete this, and you've got that. And all the calculations down, and as soon as I click out here, I get a lot of calculations to change. And I can go Control Z, which backs things up, puts things back the way they were. Okay, deleting, inserting, stacking, augmenting, stuff like that, and getting a piece of a matrix. They've also got a function called submatrix. So you can get a so this is getting an individual value in the matrix. The submatrix is getting a bigger piece of the matrix. I'll let you read about that. I just, kind of want to give you guys the headlines of what's going on here. Okay, systems of linear equations. That's probably what most people want to use a matrix for. Oh, one thing I wanted to do before I go there. If I want to refer to one column in a matrix, we also have this. This is one row. This is one column. The norm of matrix determinant, in essence, you can transpose a matrix. So here's some operators you can do on matrices and all the different functions. I'm going to get into one of the functions in particular, which is very useful. Column 2 of A. 2, 4. There it is. 2, 4. Row 2 of A. Row 2.
Oh, yes, they fixed that. Because in the book you had to do like this flip of
Right.
column.
Yeah. Okay, let's see what else. Right here, watch out for the origin. If I change the origin back to 0, look at all the things that don't work. The first row is row 0 when this is true. The first column is column 0 when this is true. If you want the first column to be column 1, you got to do this. Okay? Watch out for this origin thing. Now, solving equations. Let's set B back to what it was before. In fact, if I just get rid of this, well, I won't, because it'll mess up things from before. I'm just going to put B back the way it was. B equals the first column of B. Grab the first column of B. There it is. Okay, 5, 7. So I want to solve AX equals B. And we already have a C, so I'm going to go D, assigned equal. I'm going to augment. I'm going to put A and B side by side. And I wonder if it likes this. Good. So A is 1, 2, 3, 4, and B is 5, 7. Oops. It doesn't like that. E assigned equals. This is the same function you use as in MATLAB to solve equations. What it does is it manipulates these so you get the identity matrix in the left-hand two columns and the answer in the right hand. So the solution is AX equals B, then X will be negative 3, 4. X is this. Well, let's do this. X assigned equals E, and we want the third column of E. Oops. A times X equals B. Voila, you got it. This is the RREF stands for reduced row echelon form. When you guys get into matrix methods, you'll find out about that. It's basic.
Kind of weird doing that when you don't know what it is. You're just like, oh.
Right, yeah. You can do it this way. Now, the reason we like this is computationally fast. The inverse is not. Let's see. We haven't used symbol F yet. F assigned equal. Oops. What's going on there? Okay. F assigned equal A raised to the negative 1 power. That's the inverse of A. You can do that. And you get this. Right. F times B should equal the answer. I'll make this equal to Y. Y assigned equal F times B. Oops. I hit the return instead of the equal sign. There we go. Equal sign. Negative 3, 4. So this should equal X. Well, here's X. There we go. And here's the inverse of A times B. And just to convince yourself, A raised to the negative 1 power. Oops. Times B. That's the solution to AX equals B. It should give me the same thing as Y. There we go. And it should give me the same thing as this here, the reduced row echelon form answer. Come on, why can't I select the column? Anyway, get real, you silly thing. What are you doing? Okay. Yeah, it should equal negative 3, 4, what the reduced row echelon form tells you. It should equal the inverse matrix times B, or more directly, inverse matrix times B. This solves this. This is the solution to AX equals B. Okay, most of the time we're going to solve linear equations with matrices, and this is how you do it. And this is matrices. Any questions? What's that now? I'm not gonna get into import and export in this class. Yeah, here's input and output. Anyway, you've lots of read Excel. You know, there's ways to do it, but it's not part of this. Not part of this class. I want you to get the simple stuff. I will go through what the final exam question should look like in just a few minutes. Okay, so that's chapter 14. 15 has to do with graphing. You guys ready for this? Any questions on 14 before I move on? Okay, graphing. Now, I've already entered my data previously, so I'm just going to copy and paste it to this new untitled worksheet so you guys can see what's going on. So we have displacement, delta here, and force in newtons. Graphing's actually pretty darn easy with this. Plots, that's the tab you would grab. Insert plot, XY plot, boom, there it is. Force, now, take a look. This is the y-axis. Force on the y-axis. It's kind of weird. You'd think this would be whatever is on the x-axis. It's not. It's whatever is on the y-axis. What's on the x-axis is down here, and that'll be delta. Where's delta on this? There it is. There's delta. Okay. Hit the equal sign, and it gives me stuff like that. I can click and drag. I can make the plot bigger. Oops, made it too big. You know, that's the trouble with modern computers in a way. They're so fast. The older computers, they went slow enough that they wouldn't, you could click and drag, and you could still see what you're doing. You know, it was going slow enough you could actually see what you're doing. This one here moves so quickly. So anyway, expanding it, it makes the numbers easier to read, as you guys can tell. There we go. Click outside. The numbers then become easier to read. You can format the numbers, stuff like that. The main thing on formatting, right here. Styles, symbol. Let's say I don't want to connect it with a line. I'm going to put in a symbol first. Instead of each point represented, well, there's no symbol right now. Each data point now will have a circle by it. And I'm going to get rid of the lines. So I'm just going to take a look at the data points, how they lie. So you can format line, well, here you've got all sorts of different ways to style things differently. Okay, so that's the easiest plot. Okay, we're going to go on to another plot. Let's see, I'm going to make a new worksheet for this. By the way, when you're doing your homework, it's probably best to do one problem on one worksheet, create a new worksheet, do the second problem on a second worksheet, create a new worksheet, and so forth. Because the variables, you might have forgotten what you did on a worksheet, and the variables change. You've assigned X to means something else later on, and then when you try to do the next problem, things screw up. Start with a new worksheet for each problem. That's probably the best advice. So I'm going to create a new worksheet, a new blank worksheet. Second problem, again, I've already entered the data, so I don't have to re-enter it all the time. This will plot two different things on the same graph. That's the point of this. Okay. Get my data on the new worksheet. Insert the plot. I want time on the x-axis. Excuse me, x-axis, not there. I want time on the x-axis. There, time, T-I-M-E. And I want D1 on the Y, D1. And it'll give me this. And in your book, it shows you reformatting. I'm not going to sweat that. Now, we get to add a trace. There's this thing up here called add trace. We get to add, we can keep putting stuff on our graph. There it is, D1 and D2 on the same graph. Okie dokie. New worksheet again. Here's something else you can do in plotting. I'm going to insert the plot first of all. I'm going to do this backwards. Now, with x-axis, I'm going to go x, Oh, excuse me, x on the x-axis, not x on the y-axis. Now, previously we defined the values that go on the x and y-axis. If you want to plot a function like this, and then once you've entered it, just click outside somewhere, voila, I've got the sign. And then, of course, you can, by the way, you can just click and drag and you can change where the axis is, and so on. The oops, there we go. Okay. And yeah, and of course you can click and drag and change the size. Axes. Let's see. There we go. So we can change tick mark values here, whether or not they're there. Let's see. We can change the scaling, and so on. Okay. So that's if you just want to plot a function, just want to see what a function looks like. Now, I'm going to show you the example in the book, too. It's rather complicated, big, long formulas and stuff like that. Let's see. There we go. So, in this class, we're not going to do integration, but you can do it in Mathcad right here. So here's a really complicated formula. X is a function of t, and I'm not going to show you guys how to enter it all. It's big and long and it's hard. Not going to sweat that too much. Have I used this tab yet? I have not. Paste it. What I want to do is show you how to, once you've got that formula, I wanted to show you how to create the graph. That's what I want to do. So I'm going to get rid of the graph I have. Come on, you silly thing. There. Get rid of the graph I have and insert a new plot, XY plot. There we go. On the y-axis, we want x of t. On the x-axis, t. There we go. So, as far as plotting goes, the hardest part, obviously the plot was easy to generate. The hardest part is this. You know, also in your book it talks about, it shows we want x of t and we want to divide it by this quantity f0 over k. So I'm going to do that. Divided by parentheses fo divided by k. Now, you should notice the scale will change. There it goes. Scale changed as soon as I change my expression here. Okie dokie. That is plotting. Not too tough, I don't think. Yeah, really, it is kind of easy. The worst part is this. Doing that. Okay. Final exam. If there's no questions on this, I'll go on to the final exam. I'm going to expect you to make a function and plot on the final exam. So, I'll show you last semester's final. It'll be on, I'll upload it to YouTube. Okay. I'll show you now, of course, the MATLAB and the Excel final will be real similar to the exams you've already seen. So I'm not planning on reviewing that, actually. If you have questions on that old exam, definitely. Okay, so really for Mathcad, I just want you guys to be able to create a function and plot that function. So I'm going to go x of t assigned equal 0.5 times, you know, I looked around to see if the acceleration due to gravity was a constant in here, and I don't see it anywhere. It looks like they have the more fundamental constants. Yeah, right. No, I think I'll stick with 9.8. And times t raised to the second power. Yeah, and you guys should recognize this from physics. Yeah, 1/2 AT squared. So that's your function. X of 1 second equals distance after 2 seconds equals, okay, and so forth. Insert a plot. Now, what does it look like versus time? Plots. Insert that plot. And on the y-axis, you want x of t. On the x-axis, just plain old t. Boom. That's the final for Mathcad. So for Mathcad, we're doing Mathcad Lite, obviously. But can you create a function? Can you graph? Can you evaluate functions? You know, that's the key points about a lot of this stuff. MATLAB is more of a programming language where you can create loops and you can create subroutines and divide up your work, a big project, into lots of smaller projects. Okay, yes?
What did you go to get the graph?
What's that now?
What did you go to get the graph?
Plots.
Plots, insert plot. Insert. You can also do, I haven't shown you polars, contours, and all that stuff either, but they're there. So I get a blank plot. Well, the y-axis, I want the x values, and the x-axis, I want time.
So the x value, okay.
It's weird. They put
The y way up here on the
the y is over here, and the x is over here. That's a little weird.
It seems like it should be backwards.
Right. Yeah, exactly. Just got to get used to it. Okay, any questions?
Maybe it's silly, but I know you said you was going to drop the test grade.
Right.
Are you going to drop any of the homework grade?
Yes. Lowest homework, lowest test.
And then the finals, those each count as 3 tests. And the final
That's right.
3 tests.
Excel, MATLAB, Mathcad.
And you just drop the lowest test of all of those things.
So we'll have 6 in the fall and then
No, actually, I will drop your lowest Excel test. So you have 2 opportunities with Excel, I'll drop the lowest. You had 3 opportunities with MATLAB, I'll drop the lowest. And you've only had 1 opportunity with Mathcad, so can't drop it, but
It's pretty easy.
it's pretty easy. Exactly.
So then if we're satisfied with our grades, really we can skip the 2 sections in the final. But I'm not going to do that. I
Right,
promise.
right.
I promise I won't.
let's not rock the boat.
Well, he wouldn't have to do it.
Okay.
He doesn't have to grade. He's just like, yeah, whatever.
Any other questions?
25.
Okay, that's all I wanted to talk about today. Thanks for putting up with this. I know it's a lot of hard work.
It's good. I like it.
So,
Not Mathcad.
and we'll work on making sure you guys can succeed in this stuff in the future. And video off now.